Kids, robots, science, and engineering. That's our Techstination. I'm Fred Fishkin. With us is Lauren Harter, Senior Educational Developer for VEX Robotics. Great to see you, Lauren.
Thanks. I'm so glad to be here.
Well, give us the overview of the work that you've been doing at VEX Robotics and maybe a little background about the company.
Sure. So, myself personally, I am a senior educational developer for the company. So, what I do is I work with a lot of the educational resources that we provide to both teachers and students that accompany the robots that we make here at VEX. So we have physical robots, and then I contribute by adding, again, some of those different classroom resources that we have, and then some of the other things that we could provide a full experience for not only teachers, but also the students that are kind of going through with all those different resources as well, from pre-K all the way up through collegiate. So that's kind of the span that we reach with the kids, which is really exciting.
And you've been involved with the competitions, et cetera, that young people get so excited about.
I have. So what's really cool is that I get to witness some of the different competitions, and then I also was a mentor for a high school competition team here just right before the pandemic hit, and we were so excited. We had a bunch of different kids from a local high school come over, and I coached them through that season, which was very exciting. And a lot of them that joined actually had no coding or robotics experience at all. They were from a private arts high school, so a lot of them were studying dance or some of those other concepts, and they came in and wanted to do STEM, and they actually made it all the way to Worlds, which was very, very exciting for them on their first season. But unfortunately, a pandemic hit and we couldn't actually get to go. But again, that whole experience was, again, just very exciting for them.
Well, hopefully things will be returning to some normalcy soon.
Yes, yes.
Now, with World Engineering Day coming up on March 4th, maybe it's worthwhile to reflect on some of the contributions people in this field have made. So many and in so many areas.
Yeah, absolutely. So we are very excited for that upcoming, and I know that just from what we do here at VEX and some of the other materials that myself and the team that I work with are working on, what we're trying to do is expose different students to STEM and engineering from a very young age, and kind of getting them those positive experiences so that they gain this sense of self-efficacy and they not only enjoy STEM but also, again, have those positive experiences with it, so then they continue to study it as they grow and then eventually get into different STEM and engineering fields. So that's one of our kind of big drives that we want to do with a lot of these different materials that we make, and again, to provide opportunities for students to experience full integrated STEM, and also a piece of that would be the engineering aspect.
You mentioned some really young kids getting involved with this. Why is it important to introduce these things to the children at a fairly young age?
So I would say there's a lot of really good, not reasons, but there's different things that we want to accomplish by exposing very young students to STEM. Why we say STEM starts early. One of those pieces is to build the foundation of future learning. So some of these really, really important skills for young students, and I'm talking, pre-K students all the way down from, pre-K, kindergarten, those types of age students between 3 to 5 years old. What we're trying to do is in that particular age group, things like spatial reasoning, executive function, which is, kind of building mental skills like working memory and flexible thinking, self-control, and motor skills, being able to kind of have these fine and gross motor skills. One of the things that we can do is we can build on those skills using robotics and using STEM. So for example, talking about spatial reasoning, when a pre-K or 3 to 5 year old student has one of our VEX 123 robots, what they can do is they can talk about how that robot should move to accomplish a maze, for example. They say things like, oh, the robot has to go forward 3 steps and then turn right or turn left. Even turning right and turning left for that young of age group is challenging, and being able to learn those different kind of spatial reasoning skills. So we want to hit on all of those different areas that are really, really important for students as they continue to learn and grow and take those skills with them as they mature. So again, that's just one of the reasons that we, say STEM starts early, why it's so important. But another thing is that young students, again, those preschool age students, can develop negative attitudes about STEM even in these ages of, 3 to 5. So what we want to do is provide opportunities for them to engage in these positive STEM experiences, particularly with some of those younger products that we have, in order to not only build on those skills that I just mentioned a minute ago, but when they have these positive experiences from that young age, they then gain interest and feel like they are successful in this area and then want to pursue things like math and science and coding and things along those lines. So that's kind of the two big areas why we want to say things like STEM starts early, not just because of the skills, but again, to get students interested and feeling good about STEM so that they continue to want to learn about it as they get older.
Interesting. And for parents who may not work in these fields and may not be familiar with all this too, is there guidance there? Maybe it can be a good learning experience for both, bringing them together.
Oh yeah, absolutely. A lot of the materials that we write not only can be done in a classroom setting with a teacher, but parents can also get involved. So if they had a 1, 2, 3 robot at home, or if there was one maybe in a local library that their student could go and learn with it there, or even at school, we have different resources that parents can do at home, such as small activities, or even we have a book that goes along with introducing the 1, 2, 3 robot to young students, and the parent can read that book to their child, which also not only gets into different literacy concepts, but also kind of gives that, extending what they may be learning in school kind of in the home space as well, and reinforces that for the student. So there's a lot of different things that the parents can do or just become a little bit more knowledgeable about with STEM. Nobody has to be a STEM teacher or a STEM expert in order to get these young students kind of exposed to STEM.
And when we talk about girls, what's your perspective on why women have been so underrepresented in this field?
I think that it can boil down to a lot of reasons. I think one of them could be that they don't see as many role models, or they maybe just don't see a lot of females kind of in the particular field that they want to pursue. I think that that's one of them. I think that another thing that kind of feeds into STEM in general and engineering would definitely be confidence in math. I used to be a high school math teacher before all of this, so I saw apprehension from students, and particularly female students, about math. Their self-efficacy that they could do things were very low. For some students, definitely not all. But so I kind of saw what that looked like firsthand, and to be able to kind of be a role model for them in that area is kind of one of the things that I definitely wanted to do throughout my career. But I think that can definitely play a factor, kind of that fear of math and fear of failure. But in any STEM related field, and especially engineering, it's not necessarily failure, it's this process of iteration. So doing things multiple times and actually being able to take one trial, learn from it, and continue to improve. So I think that changing the mindset from one point of failure to more of this iterative approach is something that could help as far as you're talking about why is it underrepresented, to kind of alleviate some of that fear. But I think there's a lot of things in that area that could be done to further promote or encourage more women in STEM.
Terrific. What is the VEX Continuum? Sounds sci-fi-ish.
Yes. So the VEX Continuum is something that we are very proud of. And what's so amazing is that it provides a STEM solution from pre-K all the way up to collegiate. And one of the things that's so powerful about the STEM Continuum is it allows students to build background knowledge from year to year to year. So if you can imagine, in the perfect scenario, the pre-K classroom or the kindergarten classroom, where these students are starting out with VEX 1, 2, 3 robots, and they're learning about all these skills that I mentioned earlier, like spatial reasoning, executive function, flexible thinking, and they get exposed to coding. Now, a very pre-K, approach to coding. We're not kind of going in there with all these devices and doing, Python, but it's adapted for that particular age group. And what's nice about that is they continue to grow from year to year to year with VEX. So we move from VEX 1, 2, 3 with pre-K to 2. Then we get into the early elementary with VEX Go, and they start putting pieces together and learning fine motor skills and different engineering concepts. And what's nice about that is that it reduces gaps in learning. So kids don't have to relearn certain things like different coding languages from year to year with different products. Because everything is the same throughout the VEX continuum, it reduces learning gaps because we can focus on new concepts from year to year, but it also reduces overlap so that the kids aren't learning the same thing from year to year to year. So that's just kind of talking about it from a student learning perspective, but from a teacher and a school type of environment, what's nice about it is that it allows for differentiation. So if I have kids that are being very advanced in a particular class, I could maybe set them up with someone in a grade higher or 2 grades higher that is teaching VEX but is doing it with a different robotic system, and maybe that particular child that is really excelling can learn because we have STEM, going from pre-K all the way up. But it can also go in the other direction as well. Maybe we have certain students with physical disabilities or something that may prevent them from building certain aspects of some of the higher robots that we have. And so we can go a little bit down in the continuum as well and really make this differentiation setting that is truly adaptable to any student that wants to get involved in different ability levels. But from another teacher perspective is that one of the things that I hear all the time, and I can compare it to being a math teacher because I've done that, is that if I had a question about teaching something math related, I can go ask the other math teacher down the hall. Or I want to prepare my kids to be good for next year, so I'm going to talk to the next year math teacher to kind of make sure that we're teaching things that align. Now, when you have the VEX continuum, you can do that with STEM as well. So I can then go ask the teacher down the hall that's teaching the same VEX platform that I'm teaching. We can collaborate, we can work with different settings, I can collaborate with the older teachers as well and then in the following grades, and we can really make sure that all the students are getting all the necessary skills that they need to, again, kind of reduce that gap and also reduce overlap as well.
And with some of the products, can you give us an idea about availability and pricing?
Yeah, as far as some of that different stuff goes, so I know that some of the things that we currently had were on back order just because we had a large kind of fulfillment of orders, but I know that VEX 1, 2, 3, even just buying one of them for at home is, I believe, only, I think it's $99 just for having just one. I'll have to double check on that. It might be $119 now. But anyway, definitely under $150, $119 or so for one robot that you can have at home is not a huge price point as far as, getting started with robotics. Now that can go, for some of the other classroom elements that we have, like classroom bundles or having, 5, 10 robots in a classroom, that can obviously get a lot higher. But again, it's flexible as far as, do I just want kind of one robot, one kid, or do I want 30 different ones, so I have one-to-one with my students. So
right.
It varies.
You work with a lot of schools.
Yes, we work with tons of schools. I believe VEX is in, I think it's 62 countries or something along those lines. We'll have to double check on that. But we also produce something called VEX Code VR, which is a virtual robotics setting. And I believe we had submissions from, I think it was 62 countries. I can double check on that. But it's very interesting to see how something that you've helped contribute to is, touching students all over the world, which is very powerful.
Terrific. For more information, where can people go?
They can just go to vexrobotics.com. And what's really nice about that is that it shows you all of the different, not only products, but the educational support that I was talking about a little bit earlier. And you can kind of get a glance into the continuum and also what it looks like to see some of these different supports that we offer.
Well, congratulations on the work that you and the whole team there really are doing.
Thank you.
Lauren Harter, thank you for taking the time with us.
Thanks so much.